Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today trapezoids. This will include ordinary trapezoid. This will also include isosceles trapezoid, and we shall be solving for unknown diagonals, unknown sides, and unknown angles. Okay, so we're going to see the problem set in the worksheet. Okay, let's check on our worksheet. There. Okay, here's our worksheet, and we're going to have about 8 diagrams. Okay, 8 diagrams. So this will be our lecture examples, and the first part will be finding length of base. And let us see that first 2 problems. Okay, here's the first. Find the length of the base indicated for each trapezoid. Number 1 is find the side TW. Okay, that is the lower base on this figure. Now, we have here the 2 bases, the up and bottom base, the upper base and the lower base, and the median. Now, the formula for the median is just the sum of the 2 bases divided by 2. So it's basically the average. So we shall start with our solution. So the solution is to determine the formula for this. We have BA, this is equal to UV. So that is UV plus the base TW. And then this should be divided by 2. Okay, this will have to be divided by 2. Now we shall place a division line here for our formula. Okay, so this is our formula. So it's basically the average of the bases is the median or mid segment. Okay, so let us substitute the equivalence of these segments. BA is 2x plus 1. So this will be 2x plus 1 over here. 2x plus 1. Okay, and now this is equal to UV, which is 6. So this is 6, then added to TW. Our TW is x plus 5. X plus 5. And so this will be divided by 2. Okay. So 6 plus x plus 5 divided by 2. And we shall place the division line over here. Okay. Now we shall simplify this by multiplying both sides of the equation by 2. So we shall multiply both sides of the equation by 2. So 2 times 2x plus 1. And this is equals 2 times the quantity is 6x plus 5. So we shall put this in parentheses, 6x plus 5. 6 plus x plus 5. There. Now only the 6, okay, without the asterisk. All right, so this will now be 6 plus x plus 5, and this will still be divided by 2. And then we have the division symbol over here. And so this number 2 divides by this number 2. And we have the next part of the solution. We will have the left side 4x plus 2. And the right side will only be just 11 plus x, the sum of 6 and 5. There. And so we shall solve for x here. Subtract x from both sides, so minus x. And minus x here. And the next line will be 3x plus 2 equals 11. Subtracting the 2 from both sides now, so minus 2 and minus 2. The next line will be 3x equals 9. And we shall make use of division. So 3x plus 9, we shall divide both sides by 3. So we shall do the continuation over here. And we will be writing 3x equals 9, and then we shall divide both sides by 3 and by 3 over there. Then we put the division symbol. There. And we now have x is equal to 3. So x is equal to 3. There. Okay, now we can solve for the requirement. Find TW. Okay, what is TW? So this is TW, which is equivalent to x plus 5. And so this means 3 plus 5. 3 plus 5. And we have the answer. TW is 8 units. There. Okay, so we were able to determine the base. Okay, this is actually the base. There. Okay, and so we shall verify from the computer. The answer is 8, and you can see the answer below the diagram. It's over here, down there. Okay, all right, so that's it. This is for our first number. Let's continue with the second. Let's clear the screen and continue with the second question. All right, here's number 2. Find the length of the base indicated for the trapezoid. All right, so we have here WT. Find WT. So WT is the upper base in the diagram. Now let's determine our formula. The mid-segment MN, let's use capital letters, MN is equal to TW or WT plus UV divided by 2. Okay, so this will be divided by 2. And then we put some division line there. Okay, so that's it. This is our formula. So we shall substitute the expressions assigned to each segment. Mn is 3x minus 4. So this is 3x minus 4. And this is equal to WT. WT is 3x minus 2. So we shall put it over here, 3x minus 2. And then we will add the UV, which is 2x plus 3. And then we shall divide the sum by 2. Okay. And this will be with a division symbol over here. Okay. So we substituted 3x minus 2 in place of WT, and we substituted 2x plus 3 in place of UV. Now we will have to solve for x. Okay, so we shall start simplifying the numerator at the right side. So the left side will remain 3x minus 4, and this is now equal to, okay, 3x and 2x, that sums up to 5x, and then negative 2 plus 3, that will just be a positive 1. And then this will still be divided by 2. And so that will become the right side. There, okay. Now we shall multiply both sides by 2, okay? Multiply both sides by 2. So we will have here 2 times 3x minus 4. And then this is equal to 2 times, okay, we have 5x plus 1. And then divided by 2, okay? There, and we have the division symbol over here. Okay, now the number 2 cancels out, of course. This number 2 and this number 2. And we shall have the simplification on the next line. This will now become 6x minus 8. 6x minus 8 and is equal to 5x plus 1. And then we continue by way of subtracting 5x from both sides. There. The next line will just be x minus 8 equals 1 there. And then we continue by way of addition property, add 8 to both sides. And then we finally have our x value. Our x is 9. X is equal to 9 there. Okay, now we are ready to determine WT. Okay, WT is 3x minus 2. We shall do it over here. So we have solve for WT there. Okay, so this will now be like WT is equal 3x minus 2. 3x minus 2. And so we will substitute the value of x, which is 9. So 3 times 9 minus 2. Okay, and we shall have something like 27 minus 2, and that should be about 25. So WT is equal to 25 units there. And this is our answer. So that's it. And we shall verify from the computer. Okay, you can see the answer below the diagram there. Okay, so it's right here there. All right, so that's it for our find the base examples. Let's continue with the next problem. Let me clear the screen and proceed to number 3. All right, let's proceed to number 3. Okay, here's number 3. Find the measurement of the angle indicated for each trapezoid. All right, find the measure of angle K. All right, find the measure of angle K. So we're after the measure here. Okay, now the figure is an isosceles trapezoid. You can see the marks. Okay, you can see the marks there. One over there and one over here. All right, that means there are 2 equal sides on both ends. Those are 2 equal sides that makes it trapezoid. Okay, isosceles trapezoid. Okay, now the parallel sides are this. These are the parallel sides. Now in an isosceles trapezoid, the base angles are equal. So so that this is equal to this. Okay, these 2 angles are equal. Okay, now angle angle M and angle N are supplementary because these are part of the 2 angles on one side of the trapezoid. So a trapezoid a trapezoid has its bases parallel, okay, like this, and then you have this side. Now if you have this parallel like that, if this is parallel, you can take this side as a transversal, and then we have a theorem there. Okay, the 2 angles on the same side of the transversal in a parallel pair of lines are supplementary, so that this added to this is equal to 180 degrees. Okay, they are supplementary. Okay, all right, so just reviewing the same side in interior angles. Okay, theorem. All right, so we can have our solution now. Let me just clear my illustrations there. All right, so let me just clear it so that we can type something there. All right, so that means we can start with angle M. Okay, these are angles. Angle M plus angle N, right, must be equal to 180 degrees. This will be our working equation. The angle M plus the angle N is equal to 180. So we're talking about, okay, let me clear my markings there. Okay, all right. This angle this angle and this angle are equal. Okay. Now, this angle plus this angle is 180. Okay. All right. That's the explanation. So once we obtain the value of n, we will be able to get the value of k because n is equal to k. All right. So that will be our way of solving it. Okay, so we shall proceed to our solution. Angle M is expressed 3x plus 105. So we shall replace our working equation with 3x plus 105. And then we will add angle N, which is 3x plus 75. And it's equal to 180 there. Okay, now solving for the equation, this will be about 3x plus 3x is 6x. And then 105 plus 75 is exactly 180. And we have another 180 on the other side of the equation. So when we apply subtracting a 180 from both sides, we're going to have 6x equal to 0. So we will have 6x is equal to 0. And that means x is just 0 after dividing by 6. So we will have 6x is equal to 0. And we divide by 6. We divide by 6. And we put the division symbol over here and over here. And we get x equal to 0. Okay. And so x is equal to 0. Okay. Now we are ready to determine the angle n. Okay. The measure of angle n. So solving for angle n. Solving for angle n, we have angle n is equal to 3x plus 75. 3x plus 75. And now we will substitute the 0 there. So this will be 3 times 0 plus 75. And angle n is 75. Angle n is 75 degrees. There. Okay. Now remember, angle n is equal to angle k. Okay. Solving for angle k. All right. We have angle k is equal to angle n. So angle k is also equal to 75 degrees. There. All right. So our answer will be 75. Okay. That's the value of angle k, the required. All right. Let us check the answer below the diagram over here. There is the answer, 75 degrees. All right, let's proceed to number 4. Let's continue with number 4. This is the next diagram. Find the measurement of the angle indicated in the trapezoid. Okay, what kind of trapezoid is this? We have, again, the marks. You can see the mark there. All right, that means this is an isosceles trapezoid. And we know for an isosceles trapezoid, the base angles are congruent. Okay. All right. So that means this angle U is equal to angle T. Okay. Angle U is equal to angle T because this is an isosceles trapezoid. Therefore, we have the following as given. Okay. We have the following as given. Okay. Angle U is equal to angle T. There. Okay. There. Now, angle U is equal to angle T. Therefore, it is justified to write also angle U is equal to 50x plus 5. And therefore, angle T is also equal to 50x plus 5. Okay, 50x plus 5. Okay, all right, there. And so we can make use of the next, okay, from the same definition, we have angle T and angle S are supplementary, okay, meaning the sum is 180. So we have something like angle T plus angle S is equal to 180 degrees. And so we can now use 50x plus 5, 50x plus 5 plus angle S, which is 34x plus 7, and this is equal to 180. Okay, all right, so we solve for x first. All right, so this gives us 50x plus 34x. That looks like 84x, and then we have 5 and 7, that'd be plus 12, and is equal to 180. Applying subtraction property, subtracting 12 from both sides, which is minus 12 there, and so we will have 84x. This will be equal to 168 there. All right, 168, and then we will proceed by division. We divide by 84. Okay, so 84x is equal to 168. We divide by 84 by 84 there. Okay, all right, so we shall have our division symbol there. The left side is divided by 84, the right side is divided by 84. X is equal to how much is that? X is exactly how much is that? That will be 2. Okay, all right, yes. Okay, so X is equal to 2, and we're now ready to solve for the required. We're after the measure of angle S. Okay, so solving for S now over here. Solving for angle S. Okay, so we will have angle S, and this is 34x plus 7, 34x plus 7 there, and so S is equal to 34 times 2 plus 7, and S is equal to 68 plus 7, and that will be about 75. Okay, angle S is 75 degrees, and this will be it. Okay, that's the answer. Let's see the answer from the computer. You can see the answer below the drawing, below the diagram there. Okay, all right, so that's it, and that goes to our number 4. Let's proceed to number 5. Let's have number 5. Here is number 5. Find the measurement of the angle indicated for the trapezoid, for each trapezoid. Okay, this is an ordinary trapezoid, and the parallel pair of sides are ST and RU. But still, angle T here added to angle U is equal to 180. Okay, equal to 180. So our formula, let's have our formula. All right, so solve for angle T. Okay, all right, so for our solution, we have angle T plus angle U must be equal to 180. This is our working equation, and then substituting the equivalent expressions, we have x plus 100 plus angle U, which is 4x plus 80, must be equal to 180. This is our working equation. And then for the next line, combining like terms, x plus 4x is 5x, plus 100 plus 80 is 180, and this is equal to 180 on the other side of the equation. So applying a subtraction property now, we have 5x equal to 0 there, and we shall have 5x equal to 0. We will divide by 5 there, and we shall have the division line there. Okay, and x happens to be just 0. Okay, x is 0, so x is equal to 0. Now we can solve for the requirement angle t. Now angle t is equal to x plus 100. Okay, is equal to x plus 100, and so this is equal to 0 plus 100, and we have angle t equals 100 degrees. Angle t is equal to 100 degrees. Okay, this is it. We have the answer, and we can figure out the answer by the computer at the bottom of the diagram there. Okay, and that's it. It's 100 degrees. All right, that will be our confirmation. We proceed to number 6. Number 6. All right. Find the measurement of the angle indicated for each trapezoid. Find the measure of t. All right. So again, from the figure, angle S is equivalent to 12x plus 15. Angle T is 22x minus 5. And when you add these two, they are 180 because this is parallel to this, okay, for a trapezoid. So for our solution, we have angle S plus angle T. This is equal to 180. And substituting the equivalent expressions, we have 12x plus 15 plus 22x minus 5, 22x minus 5, that's equal to 180. All right, let us solve for x here. Let's have a combining like terms. This will be about 34x. And then we have 15 minus 5, that'll be 10. And then this is equal to 180. We apply subtraction property, minus 10 and minus 10. We shall get 34x equal to 170 there. And we shall divide by the 34. Okay, this is now 170. We divide by 34 and 34, and we put the division line there. And we shall get x. And x is equal to how much is that? 5? Yes, 5. Yes, it's 5. So x is equal to 5. We're now ready to solve for angle t. So at the right side of the computer screen, solving for angle t. All right. So we have angle t. This is equal to 22x minus 5. 22x minus 5. And we continue with 22 times 5 minus 5. And that will be about, how much is that? That's 110. 10, and then that will be 115. Yes. Yes. So that is 115 minus 5. Yeah. It's 5 times 2. 5 times 2. Make that 110. Yes. 110. Yes. 10 carry 1, and that's 11. And so 110 minus 5 is just 105. Yes. So this will now be angle T. That should only be 105 degrees. There, okay? All right, yes. Just checking my multiplication. That's, yes, 110 minus 5. All right, so let's check and verify from the lower part of the diagram. That's 105 degrees. Over here, you can see the answer there. That's 105 degrees. Okay, that confirms our answer is correct over here. And we shall continue with the next number 7. Let me clear the screen. I hope the explanation is clear from the diagram up to the equations. And we're ready to have our number 7. All right, let me clear the screen and let me continue with the next. All right, here is number 7. Find the length of the diagonal. Okay, we're working on diagonals now. Find the length of the diagonal indicated for each trapezoid. Okay, what kind of trapezoid is this? We can see the red marks in our diagram, and this means this is an isosceles trapezoid. You can see the symmetry, and there are parts there that are congruent or equal in measure. Okay, so we have the trapezoid isosceles. That means the diagonals are congruent and we can equate them, okay? And for our solution, we have the diagonals congruent. Our working equation will be Wy must be equal to Vx, okay? There, this will be our working equation. And then using the equivalents, 2x plus 6, 2x plus 6 must be equal to Vx, which is 6x minus 14. There. And so we shall solve for x first, subtracting 2x from both sides, minus 2x and minus 2x. There. And we have left side will be 6, and then the right side will be 4x minus 14. Okay. Now we shall apply addition. We shall add 14. We have plus 14 and plus 14 there, okay? And we have the left side 20, and this is equal to 4x at the right side. And so we shall apply division. So this will now be 20 equals 4x. We divide by 4. So we shall divide by 4 and divide by 4 there. All right, so this will be our division, and we have 5 equals x. So we have here 5 is equal to x there. And more appropriately, we have x is equal to 5 there, okay? All right. And then we shall now solve for the requirement at the right side of the screen. Wy is equal to 2x plus 6. So we have 2x plus 6. All right, this will be equal to 2x plus 6 there. Okay, so Wy is equal to 2 times x, which is 2 times 5 plus 6. And Wy is equal to 10 plus 6. And we have Wy is equal to 16 units. There. And that's it. We can now encircle our answer. So this is our answer, 16 units. Let us verify the answer from the computer. There. At the left side of the screen, there's the answer, okay? All right. You can make it blink there, 16 there, okay? And this is for our number 7. We were able to solve for the diagonal, okay? Diagonal Wy. Let us now continue with our number 8. Here is number 8. All right, we have an isosceles trapezoid again. Find the length of the diagonal, okay? We're after the diagonal, okay? We have the diagonals CE and DF, okay? And we have an isosceles trapezoid. That means the diagonals are congruent. They are equal. So for our solution, we can now have the equation CE equal to DF there. And we can use the expression 7x is equal to DF, which is 6x plus 3. And now solving for x, we shall apply subtraction property, okay, to both sides. So minus 6x and minus 6x. This will now be x is equal to 3 there. And so we have the value of x. We can now use this to solve for the requirement CE. So we shall solve CE at the right side space. Solve for CE there. Okay, CE is equal to 7x. So that means CE is equal to 7 times 3. And that looks like 21. All right, CE is equal to 21 units there. And we're done. That's it. All right, the diagonal CE is 21 units. And we can verify the answer from the computer near the diagram. All right, and check it out. You can focus your eyes at the diagram. Okay. All right, here's the answer there. Okay, and that's it. This is 21 units. And this is our last number. So this will be all for now for the trapezoids, mid segment, base, and diagonals and angles. All right, so just don't forget the formulas. Okay, so this will be all for the trapezoids, and see you later for other mathematical topics. God bless.